Okay, how about intensity level resolution? Again, intensity level resolution is the one that related to quantization, and as well this is the one that determine the how many point can have or to remain from the analog information to the digital information with respect to the verticals vertical axis, okay, the fxy. Okay, again, by default the one that use the save in your computer is 8 bit per pixels. Okay, so what happen if you have a image where the intensity level resolution is changing? Okay, meaning that is it what I mean is that what happen if the intensity level resolution is less than 8 bit, or is it if the intensity level resolution is higher than 8 bit, which is 16 bit over here. So you can see that, okay, if you have only 1 bit intensity level resolution 8 bit per pixel, then of course a 1 bit, okay, 1 bit if you change into binary, you can only have one number, so it can be either 0 or 1. So that's why you only have two colors there, black or white. And then if you have 2 bits, I think this one you learn in digital system, and in system digital, I think you digital electronic or digital system. Okay, 2 bits. Okay, you have 0 0 and then 0 1 1 0 1 1. Okay, you only have how many colors? 4 colors only. Okay, 4 colors, 1 2 3 4. Again, the one that the lowest one, which is 0 0, should be black, and the highest one should be white. Okay, this one black, this one white. Okay, so this one is the gray, meaning that this gray is darker than this one. Okay, by increasing the level will increase the intensity of that gray. Okay, this one 4 bit, you have how many level? You have 16. Okay, 16 or 16 possible color. So that's why you have from 0 0 to 101, you have a 16 level color. 2 bit, you have 4 level color, 1 2 3 4, first 4 level color. And then 8 bit, again you have 256 level color. And 16 bit, which is example of one of the example use 16 bit is the CT scan, can have 65k level of color. Okay, okay, this is the effect if you are changing the intensity level resolution. Okay, you can see that okay, this one is just showing the intensity level resolution of 8 bit and below. So this one is 8 bit per pixels, this one is 7 bits per pixels, this one is 6 bit per pixel, this one is 5 bit per pixel. So you can see that by reducing the bits there, you are reducing the possible numbers, or you are reducing the level, which is this one, the level that can have the possible color that you can have. Okay, for example, like I said before, 8 bits can have 256 level of color, or 256 colors. Okay, colors. Let me use the same term as this slide. Okay, you have a 256 available colors, or 256 possible colors in 8 bit per pixels. Okay, so by reducing the intensity level from 8 to 7, 6 and so on, actually you are reducing the available color. So that's why now, by reducing the intensity level resolution of this same image of skull, you can see now the available color now is reduced, have been reduced. So that's why here you can see that this one, the changing is very smooth. Okay, especially in this area, and this area of course still very smooth. Okay, but from one to another, you can see now it become obvious. Okay, like this one. Now you see there. Okay, from here, which is very smooth changing, now there's, you can see there's a line there. Okay, there's a line, and line here. So that, why is that happen? Because now you are only have 16 gray level or 16 available color, while this one you have 256. So that's why the changing from this one. Okay, I'm sure that this area is lighter than this area, meaning that from here to here you are dropping the intensity. So that's why they are very smooth changing. But because here you have only 16 uh, 16 available color, which is very limited. So that's why with that limited color, you cannot, you know, you cannot have a very smooth changing. That's why there's a very drastic changings there from here to here, because the limitation of the color to represent that point. Okay, so again, if you keep reducing the intensity level resolution, now it become more and more obvious. And lastly, this one, which is 1 bit, now it's become a binary image. You only have two possible color, which is black or white. So that's why you don't have any choice whether to use black or white. Okay, but because I don't have example for of this image, which using intensity resolution level resolution of 16 bit per pixel. I'm sure if we have that one, actually by using your naked eye, you cannot, you cannot see the difference between 8 bit per pixels and 16 bit per pixels. Even if you see in this example, by having 8 bit, you are using only 1 bit, which is this one, 7 bit per pixel. You cannot see the difference there. Okay, so that is why by default your computer, okay, our computer system only use the intensity level resolution of 8 bit per pixel, because 8 bits is enough to trick your eyes, because your eyes, human eyes, is not if you increase more and more intensity level resolution, which is more than 8 bit per pixel, then your eyes do not have sensitive enough. Okay, don't sensitive enough, I'm sorry, don't sensitive enough to see any changing. So that's why it's not very worth to increase more than 8 bit per pixel, because 8 bit is the optimum number that you can see the changing, which is close to the analog image. Okay, by having a 16 bit or let's say 9 bit per pixel, the result are the same. Okay, there's no significant difference there to see by your naked eyes, to be observed by your naked eyes. However, so now the question is, why still CT scan use a 16 bit per pixel in terms of intensity level resolution? That is because the CT scan itself, okay, you need to, as this one is based on my personal opinion, that is because that might be because of in CT scan, okay, it's a one kind of medical imaging. So that's why the radiologist might, maybe 1 point pixel or one changing there might change the decision in terms of the radiologist decision in diagnose of something. So that's why a lot of information is better for them to to see. If the intensity a little bit change, then that might be a different decision by the radiologist in determine whether that patient is diagnosed with something or not. So that's why 16 bit per pixel is it's appropriate for doing something that related to that CT scan or diagnosed by the radiologist. However, if you talk about the normal digital image, which is our digital image that we capture by our digital camera, then 8 bit is enough, because 8 bit is enough to trick your eyes, because your eyes will see the changing is like analog signal. There's no very drastic changings like 16 bit or 8 bit, I'm sorry, 4 bit or 3 bit per pixels, because this one you can see very obvious. But by having 8 bit, now is very smooth changings there. Okay, you talk about this area over here. So that's why by increasing more intensity level resolution, which is higher than 8 bit, it's not very worse, because if you talk about increasing the bits there, then you can let's say you want to still you want to use more than 8 bit. Now the consequences is that you need a big memory to store that image, because you are increasing the resolution. Okay, again, let's say 1 pixel is 8 bit. How about the nowadays digital camera, like what 30 megapixels. 30 megapixel, if 1 pixel is equal to 8 bit, meaning that 30 megapixels should require 30 megabyte. Okay, because 8 bit is equal to 1 byte, meaning that 1 pixel is equal to 1 pixel. You need to use 1 byte to save. If you talk about 30 megapixel, meaning that 30 megapixel image required a 30 megabyte to store in your computer memory. So imagine that if you increasing the intensity resolution more and more, then it become worse, because you need a very big memory to save a single image. So that's why by default our computer, or in digital world, they always use 8 bit per pixels. But later I will discuss that one, because in this program later we still have some image which is less than 8 bit. That is because of the purpose of doing some calculation and do some hand calculation. We try to reduce the intensity level resolution so you can calculate that things. But in practical, it's very very rare to see image which is not 8 bit per pixels. Okay, it's always 8 bit per pixels by default in your computer. Okay, so this is what happened if you are reducing the intensity level resolution. Okay, this one is the same image as before. Okay, this is another way to represent what happened actually. You can see here now. Again, the same thing I already highlight in the previous slide. If you talk about 8 bit, okay, the changing is very smooth from black to white. You cannot see any lines there. It's like you are seeing the analog image by using your naked eyes. It's like you are seeing the image from the environment. Okay, it's very smooth changing there from black to white, so from black to white over here. But if you are reducing the intensity level resolution, now your eyes can see there's a borders there. There's a line separate between each and every values over there. So that's why 8 bit is practical, and by default computer are using 8 bit. Okay, if you still want to use, let's say 9 bit, 10 bit, you still see something like this. Your eyes don't have capability, or not sensitive enough to send any difference between 8 bit, 9 bit, or 10 bit, or more than 8 bits. Okay, you still see this thing. Okay, this one is same goes to video file. Okay, if you try to see any movie, if you check the format, they are always using, okay, in video format or movie format, they always use 30 frame per second or 25 frame per second. So why they use these two value? Okay, to 20 frame per second or 30 frame per second. That is because that number is enough for trick your eyes, so you can see the movie, and the movement inside the movie is very smooth. Okay, if you are reducing less than 25 per second, then you see people inside the movie moving like that. Okay, something like that. But if you make the video 25 frame per second, then you see very smooth, like you see the analog movement of the environment. Okay, instead of digital video that represent your movie. But if you are increasing more than 30 frame per second, you still see very smooth, and you cannot see any difference there. So that's why they set by default, if you talk about the video format, they always use either 25 frame per second or 30 frame per second, because that number is enough to uh, to 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 um, to trick your eyes, because your eyes is not sensitive enough to see the the any changing there, the difference between video which is 30 frame per second and the video which is more than 30 frame per second. So if you increase more and more frame, then it's not very worse, because still the higher the frame rate, the higher the capacity of memory that you need to save that video. So this terminology is also same goes to the digital image. Okay, digital image 8-bit is enough. If you are increasing more and more, then you still see like 8-bit per pixel in terms of intensity level resolution. Okay, this one I talk about the intensity level resolution, the changing of the color. Okay, not a spatial resolution. Okay, try to differentiate that one. Spatial resolution is the block or the pixel size become more and more smaller if you are increasing the spatial resolution. But the intensity level resolution is about, we talk about the color. Okay, the color, the changing of the color. So 8-bit is enough to see the changing is very smooth. Okay, so I hope you understand about that. Okay, again, then that's the issue. Okay, I think this issue of have been discussed before, the resolution. When you talk about the resolution, how much is enough? The big question with the resolution is always how much is enough. This depends on what is in the image and what you would like to do with it. Okay, so it depends. This one is related to spatial resolution. Okay, how much is enough? Is it a biggest one is good, or is a smaller is good? It depends on your application. Okay, you can see this by having this situation. Okay, this one is related to some application that image processing in security and surveillance system. Okay, this one have been done in, I think those who are in School of Electrical Engineering, they doing their research in image processing is focused more on this. Okay, security and surveillance system. So by having these two one, which one is you want to use? It depends on your application. Okay, if you talk about high resolution, high spatial resolution like this one, okay, then it's better. This one is good if you want to recognize the plate numbers by using the image processing or computer vision that we have discussed before. What is the difference between image processing and computer vision? Okay, so if you want to develop a computer vision system that one you want to recognize the plate number, then it's better for you to use the high resolution, because you can see clearly the plate number. But if let's say the system is not to recognize the plate number, but you just want to the system be able to recognize or classify type of vehicle that cross in this road, for example. So for that one, it's preferred to use this one, because even this one have less spatial resolution, but the shape of the car, it's still very obvious. And one of the advantage of using low spatial resolution like this, then you can have some system which is, you know, if you want to develop some real-time application, you need to have application that use less memory or small spatial resolution, because by having a small resolution image like this, then because the size is very small, then you can, you know, the process is very quick as compared to this one. So if you prefer to have a real-time application, then you need to use this one. But of course, if like I said before, if you want, for example, the application is for the purpose of recognizing the plate number, then this one we need to prefer this one as compared to this one, because this one is very hard to see the plate number. So that's why I said it's depend on the application. Of course, if you talk about the nowadays digital camera, they will provide this thing. Okay, the higher resolution, the higher spatial resolution image. Okay, because they want your eyes to see something very nice. Okay, but if you talk about some surveillance system, especially you want to develop system, the embedded system, where you have less memory, low processor performance, then you need to prefer this one rather than this one, because you want to, because your processor is very slow. Of course you need some small data. You have a limited space, you have a limited speed of your processor, so then it is necessary to use something like this.